Hello everyone. Today we are going to present on the topic fake currency recognition using image processing, which we have done under the guidance of Dr. Dinesh Patel. These are our team members: Harsh Sharma, me, myself, Ashna, Ishita Agrawal, Lavanya Bansal, and Pradesh. Today we are going to, this is our index page, and we are first we will see the introduction and then the problem statement, and then we will look what is image processing, and then we will know about the proposed methodology, and then we will see the flowchart and the steps involved in the project. Then we will see the result and observation, and then conclusion, and then the future. We all know that counterfeit currencies to replicate the denomination in such a manner that it resembles the original currency of the country, but it exists without legal sanction from the government. Thus, it is a vulnerable threat on the economy and it enhances inflation. So, fake currency detectors are available. They are restricted to banks and corporate offices, leaving common people and small business vulnerable. Hence, our objective is to build a cost-effective and robust automated counterfeit currency detection tool using image processing techniques which could be deployed by common people. Let's have a look at our problem statement. Use of counterfeit currency is one of the major issues faced throughout the world, especially affecting the economy and of almost every country, including India. Our objective is to test the authenticity of Indian currency notes by preparing a system which takes the image of currency bill as input and gives the final result by applying various image processing and algorithms. So what is image processing? So it is a method to perform some operation on an image in order to get enhanced image or to extract some useful information from it. And its method include image enhancement, segmentation, grayscale conversions, and many more.
So what is our proposed methodology in this model? So our proposed methodology for fake currency detection centers on image processing techniques. In this, we have input a photograph or scanned image that is given to the system. It can be of PNG or .jpng or any other image extension file. Then the image is pre-processed, removing undesirable noises using suitable filters. Then the pre-processed image is converted to grayscale image, which is as detection is performed. Then the thresholding is used to perform segmentation of image. At last, our features are extracted from segmented image, which are then converted with stored image of dataset, and the output tells whether the currency is genuine or not. So this was our flowchart of our proposed methodology. First, the input image, which is a 500 rupees or 2000 rupee note, which is then the image processing is done. Then is grayscale conversion. Then the edge detection in the image is done. Then the image is divided into segments. Then at last we have its feature extraction, and the last step includes the comparison, and it tells the output whether the given rupee note is fake or not. So these are the fundamental steps which are involved in fake currency detection. In the further slide, we will understand it in deep. First, image acquisition, then grayscale. Now, what is image acquisition? The image of the currency that has to be checked or verified as genuine currency is taken as an input for the system. The input image can be acquired using techniques like scanning the image or clicking a picture with the phone and then uploading it to the system. The image should have a proper resolution, proper brightness, and should not be hazy or unclear. Blurred images and images with less detail may adversely affect the performance of the system. Now, what is image preprocessing? The aim of preprocessing is an improvement of the image data that suppresses unwilling distortion or enhances some image features important for further processing. In this step, first image is resized to a fixed size. A fixed size of image makes up a lot of computation simpler. Next up, image smoothing is performed by using Gaussian blurring method. Gaussian blurring removes a lot of noise present in the image and increases the efficiency of the system. Now, what
Now we'll look at the grayscale conversion. So conversion of a color image to grayscale requires more knowledge about the color of image. A pixel color in an image is a combination of three colors, that is red, green, and blue. Similarly, a grayscale image can be viewed as a single layered image. Different techniques can be used to convert a colored image to a grayscale image. Grayscale conversion is mainly used because an RGB image has three channels, where a gray image has only one channel. This makes the computation and processing on images much more easier in the case of grayscale image. Next up is the edge detection. Edge detection is an image processing technique for finding the boundaries of objects within the images. It works by detecting discontinuities in brightness. The grayscale image is the input to the system. The system uses canny edge detection as it gives the best results compared to the other techniques. You can clearly see in the example given below. Next up is image segmentation. Image segmentation is the process of dividing an image into multiple parts. This typically used to identify objects or other relevant information in digital images. Shows a few examples of the techniques that can be used to perform segmentation. Here, thresholding method is used to perform segmentation, where threshold values, which are obtained from the histogram of edges of the original images, are used. So now we'll look at the feature extraction and comparison. It is a type of dimensionality reduction that efficiently represents interesting parts of an image as a compact feature vector. The features that are extracted are used for comparing with the stored features, and then the results are displayed as to the currency being genuine or fake. SSIM is used for measuring the similarity between two images. In this step, the region in which the security feature of currency notes are present are extracted by cropping the image. These features extracted are then used to compare with the stored values in the stored dataset, and the result is displayed. So now we'll cover the GUI part.
So now let's get to see the working of our final project. So this is the initial GUI. So first we have to select the currency type, for which we have to check if it is fake or real. So when we have selected the currency type, then we have to upload the image. Now first let's apply our model on a real 500 currency note. So this is the image after pre-processing. So this is the final result. So it is showing that all 10 features are passed, showing that it is a real note. Also, our output displays the SSIM score of all the features that are compared with the stored images in the dataset. Like for feature 1, feature 2, feature 3, the SSIM scores for all these are greater than zero point 0.5. Thus, the status are passed for all the features from 1 to 7, and for feature 8 and 9 it is calculating the average number of lines and then comparing with the exact value. And for feature 10, the number panel is actually checked with the original number panel, and if it is matched, only then it and then only the status is passed. So this is for the real one. So now let's apply the same model for a fake currency note. This is the pre-processed image. So by using a fake currency note, it is showing that only six features are passed. So we can conclude that it is a fake note, as we are considering that if nine or above nine features are detected, then only it will be assumed to be a real note. So here also we can see that feature 1, feature 2 SSIM score is very less, showing that the status has failed. And also the average number of lines are not exactly equal to the actual number of lines that are present in a note. So thus we can conclude that it is a fake currency note. So this was all about our model.
So now we will talk about results and observations. First, a performance analysis. It is assumed that if the currency note passed at least 9 features of 10, then the note is real, otherwise it is fake. Testing of both real and fake notes was done separately. For testing of real notes, 9 real notes of 2000 and 10 real notes of 500 were considered, out of which 15 of the total 19 notes gave the correct desired result. The accuracy was 79%. Similarly, for testing fake notes, 6 fake notes were taken into consideration. For each denomination, 12 notes in total, for which 10 of the 12 notes gave the correct required output of accuracy 83%. The accuracy of both real and fake currency notes was calculated separately, and the result is shown in the bar graph, uh, the performance analysis graph. Okay. The result for time analysis, along with the final results, a lot of images and other analysis related data is being printed by our system. If all the data is printed, then the system takes about 35 seconds to process, print all the data, and give the final results. If only the final results are displayed after processing of input image, the system takes only 5 seconds for each input image. So practically the model takes about 5 seconds to give the result of each input image. So for conclusion, we can conclude that the model takes less time, about 5 seconds, when only final results are shown, leaving unnecessary details for processing the input image. The results are also quite decent, giving almost 79% accuracy in detecting genuine currency and 83% accuracy in detecting counterfeit currency. Since currency use is a necessity for survival, and hence it is always necessary to keep in track of its originality. Thus, the proposed system seems to be useful to detect the currency to be genuine or not. For our future work involves rigorous testing and improvement in computational efficiency and further incorporation of other security features to make it most more robust and reliable so that it can be utilized in real-time mobile phone applications. This system can be further implemented for foreign currencies like dollar, euros, taka, etc. as a future scope. So this is our implemented base paper. These are the references we have used for this project. Thank you.